What's going on, Algebra 2 students? I'm sorry that I started class a little bit late. I actually kind of been stalling a little bit so I can make sure that everyone gets here. And if you are unhappy about what I'm doing, I hope your computer is buffering. I'm just kidding. I was actually just standing still. The computer wasn't slow. Anyway, can you hear my voice? Can you hear my voice? Yes, yes, no. Please type in the chat. Go for it. Type in the chat so I can see your chat. Come on, you guys, type in the chat using words. Say yes, say good morning. Good morning, class. Help me out here, folks. Is anyone there? Wait, seriously, is anyone there? Can you guys hear me? Okay, all right. I think I figured out. Okay, awesome. Good. I'm sorry. I just want to make sure. All right, cool. All right, let's get this party started. But this is the way I want to run class. I want to make sure that you guys are answering me. I want to make sure that you guys are throwing the questions back to me and answering me and throwing it all up and all that kind of stuff. Because to me, this is important stuff. That we make this class interactive. That we make this class so that way we can talk and argue and think about things. This is what that Grit Fest is going to be about. It's going to be about having no fear about getting things wrong, about being willing to answer and try, and if you fail, then try again, and if you fail, then try again, because the process of trying again is what will sharpen you. The book that I read is called Iron Sharpening Iron. All right. Now, I feel like I've done part of this with you. I feel like the last time we talked, we had some dude on a skateboard. And so I'm going to kind of cover the second half of this lesson over here. And if I didn't cover part of it with you, then I apologize, but I really think that it's not even that bad. What we're going to be talking about is how to graph things in context. This is what your chapter 7 looks like, correct? Now, what is the deal with the forward arrow doesn't seem to work. One second, I'm going to reload this thing. Sorry it's taking so long. Did my computer freeze? Because my screen froze. Huh. Frustrating. I'm sorry, you guys. I'm going to have to log out and log back in. Okay, can you guys hear me now? Awesome, this thing was working. Hello, can you hear me now? Okay, let me fix up the screen. I'll to start recording this thing. There we go. That. Yeah. You can't see me yet. Hold on 1 second. I'm just fixing everything up. I'm gonna make it so that you guys can see my pretty face. I know that you guys are really concerned about that because I'm so beautiful and everything. But wait a second. Wait for it. All right, how's that? You guys can see my face. You guys can hear my voice. Can we get class started now? I think we're good. All right, this is a really good problem. Okay. So check this out. What we want to do, and I think that this is what we're on chapter 7. What we want to do is we want to be able to relate a distance time graph to a velocity time graph. And what I mean by that is, let's talk about this guy. This dude's name is Keone, all right? And let's see. The following are graphs of Keone's distances from home in various days. For each, describe Keone's movements in terms of walking, running, and constant, all that kind of stuff. All right, explain why the velocity appears the way they do. All right, so check this out. I'm going to give you a graph using a pen that does not work. There goes that pen. All right, I'm going to give you a graph. There we go. And here's what the distance time graph is. Here's the distance this dude is away from home, and here's the time as the time goes by. Okay? Now, describe for me what your thoughts are as far as how that movement looks. Okay, what is he doing? He's walking further away. Okay, now he started slowly and began to run until he and it got cut off until he made a sprint. Yes, exactly. So he's starting slowly and he's getting faster and faster and faster and faster. It's kind of like one of those games that I play with my son, where my son loves to race. He loves like racing, and he's faster than me. I'm old and fat, so he beats me a lot. But anyway, sometimes I don't tell him that I'm racing him, just so I can get a head start, and I just start walking faster and faster and faster, and then he starts speeding up, and then I start speeding up, and I go faster and faster, and then we both break into the sprint. That's kind of like what's going on here. Our velocity is getting faster and faster and faster and faster and faster and faster and faster. Does that make sense to you? All right. Now, we would describe this using probably something like y equals x squared. In this particular case, it's not y equals x squared because we're dealing with d and t. So I'm assuming it's probably going to look something like d equals t squared. Or maybe d is equal to at squared, because it would be like some number a, because that kind of tells you the shape of the parabola, times t squared. Cool? Now, if I wanted to graph what this thing is called a velocity time graph, for the same exact scenario, for the same situation, how would that look? Would it be like this? All right, I'll give you two options. Here's the first one. Here's the second one. Would it be number 1 or number 2? Would the velocity time graph for this scenario look like number 1 or number 2? All right, I got everyone saying number 2. Exactly. Very good. It would be this one because the velocity is 0 to begin with. Then it's getting faster, and it's getting faster, and faster, and faster, and faster, and faster, and faster. So essentially, your velocity starts at 0, and then it's getting bigger, and your velocity is getting bigger, and bigger, and bigger, and bigger, and so on and so forth. Does that make sense to you? Can you now relate these distance time graphs to these velocity time graphs? Awesome. Let me go grab something. It's a dirty piece of rubber from the floor. Okay? All right. Now, what I'm going to describe for you is the slope of something. You guys know how to find the slope of something, right? It's a rise over run. Like, for example, this thing is, that's the slope of that line. Does that make sense to you? And if it had a big slope, then it would look more like this. And if it had a small slope, it would look like this. The smaller the slope, the more horizontal it gets. The bigger the slope, the more vertical it's going to tend to get. Does that make sense? Now, here's the thing, is I can describe the slope of a line, but what about this complicated tidbit right here? What is the slope of this? You get it? What is the slope of this line right here? See, the slope of a curvy thing doesn't make any sense to me at all. It doesn't have one. Actually, it could. It could have something that it could be defined as a slope. And the way we do this is we use this thing called a tangent line. A tangent line is a point that touches at only one spot. And it's kind of like if I were to if I had a curvy shape, like let's say, I'm gonna draw this very carefully. If I had a curvy shape like that, okay, and I were to take like a hill, and I were to take this tangent line and balance it, like imagine that this was like a ball or something, and I were to take this tangent line and balance this like stick and balance it on there, the tangent line would be how it balances. Because it doesn't balance at this point like this. It balances at this point like this. So the curve will have these tangent lines like that. And at any given point, it would have a different tangent line. Actually, you know, I realized that the shape that I drew is actually kind of perfect to my head. So it's like balancing something on my head. At the point that it touches my head, it doesn't balance like this. Right? It balances like this. But if I'm talking about this point on my head, then that would balance like that. It's kind of like how this thing would touch my head, which is disgusting because this is actually for the wires and this is on the floor, but I mean, Mr. Balde is a disgusting person. Anyway, this parabola does have tangent lines. It has, this is a tangent line. At that point right there, this is the tangent line. At this point right here, the tangent line is like that. At this point right here, the tangent line is like that. So the closer you get, the more this tangent line is. All right, tell me the slope of this line. Is it big or small? Look at the gray stick. It's small, right? Now, as I get over here, what is the slope of this tangent line? Medium, bigger, slightly bigger. Now, as I get further over here, what is the slope of that tangent line? Much bigger? Okay, now check this out. Check this out. This graph right here is describing exactly the slopes of these tangent lines. That is that is exactly how the distance time graph is related to the velocity time graph. Does that make sense to you? And I'm infamous for going incredibly slow on these things, so let me go faster, but I mean, I want to make sure that this makes sense to you. Yes, it does. You know what I just taught you? I just taught you the foundations of the first lesson you'll learn in calculus. I kid you not. I kid you not. Remember this thing that I just taught you, and when you get to calculus, like realize that, hey, wait a second, Mr. Balde taught this to us. That's pretty amazing. This is what calculus, this is the beginnings of calculus. This concept right here, being able to translate from this graph to this graph. Learn this now, and your life in calculus will be a lot nicer, I promise you that. I hate calc. Trig is funner for me. Well, Sam, I don't necessarily know if you've actually taken full calculus, being that you're in Algebra 2. I agree with you, trig is pretty fun, but calc can be very incredibly fun because it uses trig and all that kind of stuff. All right, let me try the next one. Well, here's the thing, to be honest with you. I would say that the calculus is only fun if you understand the foundations of it. So let me make sure that you understand the foundations of it before you tell me that you hate calculus. And the foundation of that is Algebra 1, Algebra 2, and trig. So anyway, let's try this one. Let's do this one. I'm going to pretend that I do this, and I go like this, and I go like this, all right? This is my distance time graph. I know it's a little bit different from the graph I have shown. So you know what? Let's not worry about that graph a little bit. If this is a little bit different, I want to know exactly. Actually, you know what? I'm going to do this. I want to make it more. Actually, you know what? I'm going to make it more horizontal. All right. So this is the shape of my graph. All right. Now, if I were to describe the story, it would be like someone leaves their house, walking. Are they changing their speed or are they keeping the same speed? Let me ask you that. They're changing their speed. They're changing their speed. No, they are changing their distance. That's true. But they're actually not changing their speed. Because the speed is describing the slope. That slope is the same all the way through. I'm talking about for the first half of the trip. I'm sorry, I didn't make myself clear on that. But for the first part of the trip, we'll call this the first leg. The first leg of the trip, the slope is the same. It's a constant all the way through. If it were changing, it would look like this, like the graph we saw before. Because this is a slope, and this is a slope, and this is a slope, and that's a slope. Those are constant, those are constantly changing slopes. This is just a constant, boom, that has a slope. The slope over here is the same as the slope over here. Does that make sense? Does that mean he was walking in place at one time? Well, yes, actually, Elijah. It does mean that he was walking in place at one time. It would be at this particular time. And I wouldn't say he's walking. I'd just say maybe he lied down and took a rest or something like that. Okay? Now, describe for me the third part of his trip, this long line right here. What did he do? He was walking backwards, or he was walking, he turned around and he was walking closer. Now, was he walking fast or slow? And I suppose that you would need to compare that to something. So what I say is, was he walking faster or slower than his first leg? You would say it's slower. Because he took a longer time, right? Or maybe more mathematically you would say, the slope is actually a smaller slope. This is more of a slope that's closer to a horizontal line than this one. This one's closer to a vertical line. So he was probably walking fast up here, lied down, and then slowly strolled back home. Does that make sense to you? Because understanding the story will basically help you get these graphs. Now, if I want to get a velocity time graph over here, I want to get the graph that relates to this one. So tell me, what is the slope over here? Is it changing or is it constant? The slope right here, the first leg, is it changing or constant? It's constant. It's constantly what? Is it positive or negative? There we go, because it's going up like this. All right? Now, is it big or small? Is it a big slope or a small slope? I wouldn't say it's the biggest I've seen, but it's big. It's bigger at least than that one. So I would draw a constant line that go from here to here. and I would draw it kind of big. Does that make sense to you? Now let's talk about his second leg of the trip. The second leg of the trip. Oh yeah, they're outside. They're laughing really hard at another teacher. I apparently am not that funny because you guys don't laugh at me ever. You guys type LOL, but I don't really believe that you guys are actually laughing out loud. Anyway, the second leg of this trip, this horizontal one, what is he doing? He's resting. So what is his velocity? So it bumps down to 0 exactly. So for that second leg of the trip, this is the velocity. It didn't move. All right. Now the last leg of the trip is going down. What kind of slope is that? Is that a positive slope? Is it a negative slope? Is it big? Is it small? Is it constant? Is it changing? Tell me. Describe it for me. It's small. Negative. What else? Is it constant? Changing? Exactly. It's constant. It's a straight line going down like this. Perfect. Very good. Awesome. This is what the graph looks like. Got it? I want to do this one. Are you ready? I'm going to erase, by the way. So take a snapshot. Savannah, you cannot find this handout. I think it's called handout 7. Let me double check to make sure that I'm not doing the wrong one. Because that would suck. Give me a second. I'm just looking on the computer to make sure I'm not doing it wrong. Very good. Oh, I am doing the wrong one. I stink. I'm so sorry, guys. I'm doing the wrong one. No, this one is actually from an algebra. I think this is from Algebra 1. So this is totally review for you guys. But actually, I don't feel bad. I don't feel bad about doing the wrong one, to be honest with you, because understanding this is actually really important. In fact, I'm still going to do this last problem. All right, and I'll admit to you, this is actually from Algebra 1. This is for my Algebra 1 class. So if you don't know this stuff, then you might want to beef up on this. But this is actually really important stuff. All right, let me try this one, okay? And if you guys don't know this, then I mean, yeah, I taught this in Algebra 1. But all right, here we go. There we go. Let's describe this graph. This graph right here. Here's my distance. Here's my time. Describing this graph right here is talking about what shape is that? Starts with a P. There's only one shape you've ever learned that starts with a P. Actually, I take that back. There's parallelogram. There we go. It's a parabola. It's not a half circle. A half circle looks like this. A half circle is more like this. A parabola is a little bit more pointy than a half circle. Okay? Now, would you like for me to tell you the story of what this is describing? It's very simple. You want to see it? There we go. Look, that followed the parabola shape almost perfectly. When I throw something, whenever you throw something, it follows a parabola. Which is why we want to learn about a parabola in the first place. Now, keep in mind, all right, you guys just sit back, relax, enjoy the show, because this isn't a part of your homework. I apologize, I'm actually doing the Algebra 1 review, but I think it's really important because it's the foundations of calculus. So I'm actually teaching my Algebra 1 students calculus here. But I want you to learn this as well. Describe for me, all right, describe for me what the velocity time graph looks like. So let's break this up into 3 parts. Let's break this up into journey part 1, which goes from here to here. This will be part 1. I'm going to describe it as part 2, which is only this small spot at the top over here. And then part 3 goes from here to the end. You guys get it? All right. So, whoa, what happened to my chat? So I'm going to describe this. And so now, in fact, I'm going to do this kind of quickly for you. Is this velocity, is it big to begin with? That's my question. Is it big or small to begin with? It's starting over here, but is the velocity big or small? Think about the situation. You're throwing something in the air. It starts off with a big velocity. What happens to it? What happens when you throw something up? It begins to level out. What do you mean level out? It begins to what? It becomes smaller. Exactly. When I throw something in the air, when I throw something in the air, it starts off with a big velocity, and then it slows down, slows down, slows down, slows down, slows down, and eventually goes to 0. So I'm dealing with my first leg of the trip. It starts off big, okay? And then it slows down. So over here it's smaller. And over here it's smaller. And smaller, and smaller, and smaller. Does that make sense to you? Now let's talk about part 2. Let's talk about point 2. We have point 1. Okay, our point 1 is the first leg of the trip. Now the point 2 is when it's halted in midair. At that point, what is its speed? How fast is this? Exactly, it's 0 because it's going up and its speed is positive, and at some point later its speed is negative. So if there's something that goes from positive to negative, then at some point it had to have gone through 0, right? If I'm going from the positive side to the negative side, I had to have crossed the 0 threshold, this 0 point. And that would be exactly where this lines up. 0. It goes to 0. Now, its velocity over here, is it big or small? We're talking about the point that's right next to point 2. Is that big? It's small, exactly. And then as it goes on, what happens to it? It gets negative. I love that. It gets negative and it gets bigger. Exactly. It gets more and more negative. So it actually looks like this. This, my friends, is the velocity time graph to your distance time graph. This is, in using calculus terms, this graph right here, this one right here, is the derivative of this graph right here. Now, you guys might not know what that means. That's fine because you haven't taken calculus. But when you do, realize that this graph right here is really taking the derivative of that graph right there. Now, here's my last question. Let's take the derivative of this. Let's take the derivative of the velocity time graph. Let's figure out what the other graph looks like. Is this a constant slope or is this a changing slope? I'm going to draw that graph over here. It's a little smaller. Is it a constant slope or is it a changing slope? the slope. You know, think of the line. Is the slope of this line? You would say it's constant, and I would say I agree. It's not. This is a changing slope right here, because the slope is this way, the slope is this way, the slope is this way. By slope, I mean the tangent lines. This one right here, the tangent line, is the same wherever I go. So it's a constant slope. On this graph, that would mean that it's a constant line. Is it a positive line or a negative line? Is this slope positive or negative? Think about it. It's negative. So I would say that that line actually looks like a constant line as negative. This right here is describing the acceleration versus time graph. You have distance, you take the derivative of that, that gives you velocity. You take the derivative of that, and it gives you acceleration, which is a constant line. That is telling you that something is pulling down on this object constantly. You know what that constant acceleration is called? Starts with a G. Rhymes with depravity. Or cavity. Gravity. Very good. Exactly. This is saying that gravity is pulling down on this object constantly. Which makes perfect sense, because to be honest with you, gravity doesn't, no one turns the gravity machine whenever you throw things. You don't throw things and all of a sudden everything starts to float. Gravity is constantly pulling down at the same exact acceleration, negative 9.8 meters per second squared, all the time. That is what we're describing. I basically have related something that you see in real life when you throw a basketball to the math that you should have learned. Alright, let me load up the actual chapter 7, and I'm going to go through and give you, and I'm going to say this for now. I apologize for covering something that was different for 40 minutes. I don't think that I've wasted 40 minutes of your life, because I feel like we were able to start talking and get your brains thinking and start shaping and molded, and I'm excited about that. But I'm going to give you a gift now, and my gift is this. I'm going to go and do chapter 7. I'm going to probably burn through it pretty quick, because what I want to do is give you a homework problem, or help you out with some of your homework problems. Now, you can't really hear it. Hey, Manning. All right, one second. Let me just close the front door then, so that way there's no background noise. Can you guys hear better? Is that better? Yeah, awesome. Sorry, there was a bunch of kids outside. All right. Now, also, I forgot to ask Lena. Lena, you asked me if you had a question, and I never answered it. I told you I would answer it in class. Can you make sure to ask me that question again? Okay, the other thing's loading up now, so my screen might go blank or whatever, I don't know. But anyway, let me go through this as fast as I can, as best as I can. Alright. Here we go. Solving for x. I love this stuff. Let's do it. Is this what your function 7 looks like? Alright. No. We're not doing functions 4. Lena had a question on functions 4, so she needed help. Lena, I'll make sure to answer your question sometime today. Fair enough? Alright, let's do this one. I'm going to probably do... Let's do this one. It says 2x minus 1 equals 3. I want to get x all by itself. I love doing this stuff. I actually taught my 5th grader how to do this when he was 3. Let's get x all by itself. You subtract 1 from both, or you're subtracting 1, so you want to add 1 to both sides. I've got 2x equals 4. I'm going to divide 2 by both sides. I got x equals 2. I'm going through this quickly, but stop me if you need help. Please make sure you stop me. If you don't, that's your fault. It's not mine. Okay? Fair enough? Good? All right. Well, that wasn't that hard. I'm going to erase. Let's do number 2. Because number 2 is actually harder. X squared minus 1 equals 3. All right. Actually, you know what? Number 2 is not that bad. Maybe it's number 3 that's tough. I'm going to do all 3 of them for you. One way you could do that is you could... All right, there's an easy way and a hard way. I'll show you the hard way. Subtract 3 from both sides, and you have x squared minus 4 equals 0. And then you can factor that and think of that as x, and you want something that multiplies out to be negative 4 but adds to the number 0. So I would say plus 2 and negative 2, because positive 2 times negative 2 is negative 4, and positive 2 plus negative 2 is 0. If you don't believe me, FOIL that out and you'll figure out that these are the same thing. Well, if this times that equals 0, then either x equals negative 2 or x equals positive 2. We good? Now, Mr. Dalday, why did you show me the hard way if I'd rather see the easy way? Fine, I'll show you the easy way. X squared minus 1 equals 3. Put the 1 onto that side, and I've got x squared equals 4. Take the square root of both sides. X equals 2. But I have to remember to throw in the plus or minus because I'm taking the square root of both sides. Because both positive 2 times positive 2 will give you 4, and negative 2 times negative 2 will also give you positive 4. So that's why we did that. Yes, Kaylin, yes, you could add the 1 to both sides, and that's exactly what I did. Why did I show you the hard way first and not the easy way? Well, it's because of this. I'll show you in just a second. Can you take a picture? I'm going to give you 3 seconds. 1, 2, 3. All right, I'm erasing. If that was too fast for you, all you do is take a picture, a screenshot. You hold down the control button, and you press the button that's above the number 6. That will take a picture of it, or you can watch the archive. The reason why I showed you the hard way is because this. X squared minus 2x equals x plus 2. Now, I'm going to put the 2x onto the other side. So I have x squared equals 3x plus 2. Here's my problem, my friends, is I can't solve it by taking the square root of both sides. If I took the square root of both sides, I would have x equals plus or minus the square root of 3x plus 2. Why? I can't get x all by itself. It is impossible. So the only way I can do it is using the harder way, which isn't even that bad. So the reason why I showed you the hard way on the easy problem is because this one only can use the hard way. Actually, there's 2 things you can do. There's 3 things you can do. You can complete the square, you can use quadratic equation, or you can factor it. And I believe that this one can be factored. In order to do that, I'm going to pull everything over to the left side. I've got x squared minus 3x minus 2 equals 0. Got it? Anyone confused at this point, or do you got it? Say got it or confused. Answer now. I expect Alyssa and Elizabeth and Elijah and Kanani and Lena and Mia Lang. I can't see. Those things are smart. Savannah and Travis. Got it? Awesome. Awesome. I want all of you guys to answer. Throw it up. There. Got it. Okay. Yeah, all I did was I took this x and put it over to that side. All right, since you got it, I'm not going to... Wait, where did I get the what? Where did I get the 3 and the negative 2? Well, the x, when I pulled the x over to this side, I subtracted the x onto this side. So it's negative 2x minus another x would give me negative 3x. This 2 gets pulled over to this side as well, and I get negative 2. Now, what I'm going to do is when I have all this junk equal to 0, I can use this thing called the quadratic equation. You should know how to use the quadratic equation. If you don't, that is something you need to research and get good at. You should know how to complete the square. I don't expect you to remember that step, because if you use the quadratic equation, it's using the same thing. But we could factor this, and when we factor these things, it's nice. We have x, we have x. I want something that multiplies out to be a negative number. The only kinds of numbers those would be is plus and minus. I'm realizing that you can't factor this. I'm sorry. Did I even write the problem? I did. Alright. They want to be punks about this. I admit to you, they're going to be a punk about this problem. Because I need to choose two numbers that multiply out to be 2. I can choose 2 and 1, right? Or I could choose 1 and 2, it doesn't matter. The reason why it doesn't matter is because if I multiply these out to be 2, I'll get my negative 2. But if I add these, I'll never get negative 3. So I take that back. You can't factor these. This one. You might be able to factor the next one. But you can't factor this one. So if that's the case, then we're going to have to use the quadratic equation. I'm going to do it real quickly for you. I've got, I compare that to ax squared plus bx plus c equals 0. By the way, I want a show of hands. Who knows the quadratic equation? And does anyone feel uncomfortable with it? I know this. All right, I want to make sure everyone knows this. The quadratic equation is x equals, there's this negative boy. He was unsure about going to a radical party. He was kind of a square, and so he missed out on hanging out with 4 awesome chicks. The party was over at 2 a.m. That's the quadratic equation, by the way. That's how I memorize it. Negative boy plus unsure about going to a radical party. Dude was a square. He missed out on 4 awesome chicks, and he divided it on talking to 4 awesome chicks. And then the party was over at 2 a.m. So all I do is I just basically figure out what my b is, what my a is, in this case it's 1, and what my c is. So my b is negative 3. So x is equal to positive 3, because it's negative 3, plus or minus the square root of negative 3 squared, which is 9, minus 4 times 1 times negative 2, so I put a positive there instead, all divided by 2a, so that would be 2 times 1, which is 2. So I have x equals 3 plus or minus 9 plus 8, so that's the square root of 17 over 2. Does anyone know what the square root of 17 is? I would say it's about 4.1. I'm just guessing, I don't know. Use your calculators, 4.1. So I would say this is x is equal to 3 plus or minus 4.1 over 2. All right, why did I put a positive 2 instead of a negative? Okay, I'll tell you why. Because this, what I did was, I plugged it into here. I like your question. Why did I put a positive 2 instead of a negative? Because you're right, c is negative 2. That is true. But I accounted for this negative. See the minus 4ac? I put a plus 4ac. That accounted for my negative over here. Does that make sense? Okay, good. I'm going to erase this. Take a picture. 3, 2, 1. Jeez. All right, erasing. All right, let's do the next one. All right, so I trust that you guys can do the rest, because the rest are quadratics. You guys want one more? You want me to do another one for you? All right, let's try this one. I'm going to do number 6. X squared equals 7x plus 8. Again, I'll take everything over to the left side. So I've got x squared minus 7x minus 8 equals 0. because I just subtracted 7x, subtracted 8. In this case, I'm going to use a quadratic equation just because I like it. X equals negative b, so that's positive 7, plus or minus the square root of 7 squared, which is 49, minus 4ac. But notice, Kaylin, that the c is a negative number, so instead of saying minus 4ac, I'm going to say plus 4 times 1 times 8. Cool? All divided by 2a. And by the way, I love that you asked me that question. I'm not upset, I'm not teasing you that you asked me, where does that positive 2 come from instead of negative 2? I want you guys to scrutinize my work. I want you to take a look at it and say, I understand where that comes from, or I have no idea what he's talking about. All right, let's keep doing this one. Let's see, that's 7 plus or minus the square root of 49 plus, all right, what's 4 times 8? I'm not really good at that kind of math. What is 4 times 8? 32. Can you add 49 to that for me? 32 plus 49 is what? It's 81, isn't it? Yeah. Over 2. Hey, I like the square root of 81. Square root of 81 is nice because it's 7 plus or minus 9 divided by 2. Alright, so those are our two answers. It's 7 plus 9 divided by 2. Let's see, 7 plus 9 divided by 2. Alright, so 7 plus 9 is 16, divided by 2 is 8. Either the answer is 8 or 7 minus 9 divided by 2 is 7 minus 9, negative 2, negative 1. Very good. I agree. Do you guys like it? All right, now, 1 second, before I do this, before I move on, before I erase this, what is the point in the 1 of the, oh, you're talking about what is the point of this thing? Is that what you're asking? Oh, okay. I just wanted to put the parentheses around that 1 to make sure that I remember that is 4ac. It's 4 times a times c. I put the parentheses around there because I don't want to think that that's 41. And by the way, a is the number 1. When there's nothing out here, it's just a 1. All right. By the way, just to let you know, not to piss you off or anything, but this could have been done the easy way. I did it the hard way. It's the quadratic equation. A lot of big numbers, a lot of things to worry about, a lot of pieces to the puzzle. I could have, however, factored this as x. What are two numbers that multiply out to 8 and add up to negative 7? Well, I would go positive, negative, and probably do an 8 and a 1 over here. Exactly, because negative 8 plus, or negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. So from here, I could have just gotten my answer. Look, it's negative 1 and positive 8. Factoring. I knew that because the quadratic equation told me that these answers would be nice. In the previous problem, the answer wasn't nice. It was like 4.1, 3 plus or minus 4.1 divided by 2. That was a weird answer. This one is a nice answer. It's 8 and negative 1. That tells you that you could have, however, done it by factoring, and it would have been a lot easier. It would have just been these 3 lines instead of these 10 lines or whatever, 8 lines, 7 lines, whatever. The quadratic equation is kind of like, all right, wait, I got somebody coming in. What's up? Oh, just sit on my table. Okay. And something else. Did you need? Great.
Sorry.
No, don't worry about it. The quadratic equation, I describe it as like the bazooka. Because to solve an equation like this, you could use this nice, elegant, I think of it as like killing a fly. So there's this fly hanging out, right? There's the fly. Now, I could do one of two things. I could use a fly swatter and kill the fly. That's a nice, quick, elegant, clean way. Or I could do this. Maybe you guys know what that is? Right, exactly. I could use a hand grenade. I put a hand grenade right by the fly. Boom! It would probably kill me in the process, but it would work. Well, to me, that's what the quadratic equation is. Quadratic equation will always work. Is it the cleanest? Is it the fastest? Is it the prettiest? No. The prettiest solution would be the nice, elegant, clean solution. But the quadratic equation, Garens, Bobarens, you will kill that fly. You will factor that equation. You will solve it. It will take longer. It will be harder to work. The cleanup will be a lot uglier, but it will work. So it's up to you, really. You can choose to use the fly swatter or the hand grenade. By all means. How many races, by the way? Give you 3 seconds. 1, 2, 3. All right, there we go. I apologize, I didn't get as far on this as I wanted to. Let's talk about this one. Pablo and Sienna live in a tall building. Sienna loves to fly her remote control airplane to the top of the building, and the buildings are of their building into the building's common pool. Wait, she flies her airplane into the common pool? Why would you do that? That breaks the airplane, doesn't it? I don't understand these people. Anyway, the height of the airplane in T seconds. All right, wait. The height of the airplane in T seconds after she releases it is a negative T plus 100. Pablo is jealous of his sister since he isn't old enough to join her on the roof, so he leans out over the 20-foot high window and throws a rock straight up in the air with all of his strength. All right. He releases the rock, and this is just so many words. Anyway, apparently the rock, as a function of time, is negative T squared plus 50T plus 20. Got it. Natural question Pablo asks is, does Pablo have a chance of hitting the airplane? Sweet! If his rock is going to hit the airplane, the height of the rock, of his rock at some point must be equal to the height of the airplane. In fact, he would like to know all t such that r of t is the same. Okay, there we go. So let's see. So this graph right here describes the rock as a function of time. It looks like a parabola, which makes perfect sense because even though I was doing the Algebra 1 lesson with you, remember, things that go like that, things that are under the influence of gravity, is a parabola. By the way, I can tell you, just by looking at these numbers, that they are talking about gravity and they're measuring things in feet. Because gravity is negative 9.8 meters per second, whereas gravity is negative 32 when you're talking about feet per second squared. And these guys are always describing half of gravity, so negative 16 I can tell that they're using feet. This is just a side note because I'm a physics guy. But anyway, this is the graph of his sister, throwing from the roof, which is 100 feet tall, and it's going into the pool. So there's a chance that Pablo could throw the rock up and hit his sister's glider, or airplane. Does that make sense to you? Now what they did was they added these functions, and then they said, okay, well this is a, is that plus t? No. This is the rock minus a. Okay, it's a little weird. Actually, that makes perfect sense to me. Think about this. if a of t is a function and it represents the height of the airplane at a given time t, okay? You guys get it? And r of t, which is some other function of t, is the height of the rock at a given time t. In fact, I can tell you the exact equation of it. This is negative 22t plus 100. This is negative 16t squared plus 50t plus 20. This is describing the height of the airplane at any given time. This is describing the height of the rock at any given time. If those two were to collide, what would you say? What can you say about the height of the airplane and the height of the rock? If the rock did indeed hit the airplane. They would have to be at the same height exactly. They would have to be, if the airplane's over here, if the rock hit it at some point, then at that exact moment in time, say 5 seconds into the, or 2 seconds into the flight, they would have to be at the same exact height. What would the distance in between them be? If they're at the exact same height, what is the distance that's in between these things? Zero. Shoot, I can tell you how to solve this thing already. I'm wondering why they graphed r of t minus a of t. And I would say that what they're doing is, I'm actually telling you the answer. I think that they're going to build up to this answer, but I think that we can figure this out already. I think that we can say that whenever this is equal to 0, whenever the height of the rock is minus the height of the airplane is equal to 0, that's when it has the potential to collide. Does that make sense? So they graphed the whole function r of t minus a of t. But really the only points that we have to worry about is whenever that difference is equal to 0. So I would say that your best candidate is at 2 seconds. And also at 2.5 seconds. In fact, let's just try this out. Just to try. Okay? Let's plug in 2 into here. So what is a of 2? Well, that's negative 22 times 2, which is negative 44, plus 100. That's 66, right? What is r of 2? Okay, fine. That's negative 16 times 2 squared, which is 4, plus 50 times 2, plus 20. Okay, help me out. I don't know how to do this math very quickly. What's 16 times 4? Is it 64? So what is negative 64 plus 120? It's 56. Wait, 1 second. I did this wrong. Duh, what is negative 44 plus 100? What's going on, Tejas? Hang out there for just a second. Come on back in. I'll get you. Right? This is 56, and negative 44 plus 100 is 56. Boom, my friends. Check it out. Look, at exactly 2 seconds, the rock is at the same height as the airplane. I would make a very good case that that is when the airplane hits the rock or the rock hits the airplane. Pablo, you're such a jerk. You broke your sister's airplane just because you couldn't go up on the roof. What a bitter, bitter person you are. That's cool because basically we solved this problem, and they said rather than completely answering this question now, let's return to it at the end of the lesson. Well, we figured it out. I'm sorry. I just have a tendency to do that. I'm sorry. Well, she was already throwing it into the pool. I agree with you, Elijah. Why would you throwing your remote control airplane into a pool? It deserves to be hit by a rock. All right, I'm going to erase this. By the way, where did I get 2 from? How did I know to plug in 2 for time? From the graph, exactly. Because that is the time in which the r minus a graph is equal to 0. And I told you, or you told me, that r minus a, if I were to graph that, that's talking about the distance in between those two objects. If that ever equals 0, that means they're on top of each other. That means they are colliding with each other. So anytime that this graph right here is 0, that means they are hitting each other. So where would your second guess be? Say that somehow it misses at 2 seconds. Where would you say another good chance of it hitting would be? At 2.5 seconds, exactly. We cool with that? Now, say that you didn't have the graph. In fact, actually, to be honest with you, this might actually be the thing I need to end with. And then, Liana, give me a call at about 1 o'clock. My number is 441-8027. And I will help you out with that one homework problem that you're having trouble with. Okay? All right. I'm going to do this one with you really quickly because I got to start up my next class. Actually, technically, I should. No, I've got some time. I'm going to end a little bit early, though. Well, no, maybe not too early. All right, here, let's do this one. How would we mathematically figure out what this is without looking at that graph? Well, I'll tell you. In fact, I'm going to do it for you quickly, if that's all right. And I apologize. To be honest with you, I have no idea what they have in store for you. Oh, okay. So they're just asking. Actually, I really like that, Kaylin. Let's do that. Saying that a of t. Actually, you know, I'm going to do a different. I'm going to take a different route, Kaylin. But what you're saying is absolutely correct. I'm going to figure out what r of t minus a of t is equal to. So I just replace r of t with what it's equal to. So that's negative 16t squared plus 50t plus 20. And I subtract this over here. Now watch it carefully. Plus 22t minus 100. Go for it, ask me. Why do I have a plus 22 and why do I have a minus 100? Isn't it negative 22 and plus 100? Come on, you guys. Chime in. What's your thoughts? Why is there a plus 22? Why is there a minus 100? Ah, exactly. When I'm subtracting off a of t, it changes the signs of all of these things because I'm subtracting off all of this stuff. So you can kind of think of it like this. I'm subtracting off a of t, so that becomes positive 22t, negative 100. Now what am I going to do? I'm actually going to simplify this a little bit. And I'm going to simplify this as negative 16t squared plus 77t minus 80 equals Oops, whatever. I didn't put an equal sign because this is technically exactly what r of t minus a of t is. Now, when I set it equal to 0, that's when I'm describing something. I'm asking the question, when are they exactly 0 feet apart? And that is why I say, Kaylin, you did such a great idea, because you said a of t is equal to r of t. Technically, that's saying the same thing. I just move this a of t onto that side of the equation. I have r of t equals a of t, or a of t equals r of t. That's saying the exact same thing. I just set it equal to 0 this time. How do I solve this? Well, I can solve this using the quadratic equation. And I can just say t is equal to negative 77 plus or minus the square root of 77 squared minus 4 times 80 times 16. Notice how this still says minus, because it's minus 4 times negative 16 times negative 80. Those two negatives cancel out, and so this still says minus. That could be a problem. That sometimes tends to be a very scary thing. All divided by negative 32, because negative 2 times that, or 2 times that. All right, help me out here, folks. What is 77 squared? What is 77 times 77? 5929. What is 4 times 80 times 16? Come on, I don't have a whole lot of time. We've got to run this quickly. $5,120. 5,120. All divided by negative 32. What is 5,929 minus 5,120? $809. Take the square root of that. What's the square root of 809? $28.442. All right. All right. Now, what I want you to do is do negative 77 plus 28.442. Okay? That should give you like negative 50 something. Oh, I'm sorry. I don't know why I have 2 there. It should be negative 32. What is, all right, negative 48. All right, divide that by 32. Divide that by negative 32. That's a problem. That is a serious problem. You understand my problem is I didn't get 2. I was supposed to get the number 2. All right, let's try this. Let's try this. What is negative 77 minus 28.442? So add 77 to 28.442. All right, now divide that by 32. Or divide that by negative 32. Alright, so my answer is either 1.57 or 3.295. And I'll be honest with you, I don't know why that came out like that. I'll be honest with you too, I'm out of time. I'm so sorry, folks. Give me a chance to think about what the problem is here. And we'll come back to this. Fair enough? I'll have to take a look at it though. Someone do me a big favor too. Someone take a picture of this page and send me a copy of that picture. Take a screenshot, send me a copy so I can remember, because I got to erase this for my next class. Let me just look at something real quick. Negative 16 plus 50t plus 20. Is that the actual equation that we use? Because watch, turns out I wrote it down wrong. No, we didn't. Negative 16t squared plus 50 plus 20. Then they said negative 22t plus 100. So when I subtract that, I get this. Negative t squared. Alright, you know what? To be honest with you, normally I would say that this is much more accurate than looking at a graph. There's no way you could get this wrong if you're looking at a graph, you can't get it wrong. This one should be super accurate. The problem that I have is we tested out 2. We saw that if you plug in 2 here, then these will both be equal to 56. That's their height. So I don't know why this isn't the number 2 and this isn't the number 2.5. Something must be funny here. I'm wondering, you guys double check this for me. I almost feel like maybe, just maybe, you guys didn't plug this into your calculators correctly. I'm not blaming you. I'm just saying that might be its case. Check that out for me. I gotta go. I'll talk to you guys later. See you around. Okay, and Lena, call me up. It's 1 o'clock, and I'll help you out with that one.